Hello MATLAB students! First we're going to review what we've talked about in class, relational operators. So we've used them in math class. Is 4 greater than 3? And the answer is 1, or true. Is we can have more complicated expressions. Is 2 plus 2 exactly equal to 3 plus 1? And we get 1 for true. Is it greater than 0 for false? So we can have these expressions and they're either true or they're false. We can even have a variable x is equal to 5. We can say is x greater than 0, and the answer is true. So keep that in mind, and we're going to look at a little script, just 5 lines long. We'll start out with an x set to 5, and then we're going to test, is that variable x, 5, greater than 0? That's going to be true. And now, instead of an if statement, which we've learned about, we're going to have a while loop. So while is kind of like if. We test if something's true. If you're true, you go inside the loop. And the only difference between the if and the while is once we're done executing the lines of code inside the loop. For a while statement, we go back up to the start and we test, is that expression still true? And it gives us the ability to execute lines of code multiple times. So the first time through the loop, x is 5. This is a true statement, and so we'll go ahead and print x is equal to, and we plug the value of x in place of this %d. So we'll print x is equal to 5, and then this line of code decreases x by 1, and x will be set to 4. We go back up to the while loop and we say, is this still true? Is it still true that x is greater than 0 and 4 is greater than 0? So we'll go ahead and print x is equal to 4, decrease x by 1, it'll be 3, etc., until we get to a case where x is not greater than 0. So if I run it, I see that it goes inside the while loop 4 times, because this statement is true when x is 5, 4, 3, 2, and 1. But once we get to the position where we're left at the end, where x is 0, 0 isn't greater than 0 anymore, so we stop with the while loop. So if I were to change my starting number to 3 and I run that, then it goes through the loop 3 times. But what if I change this expression and I say while x less than 0. So while the variable x, which has 3 in it, is less than 0, well, that's false right off the bat. So we end up not even going into that loop at all. We don't do the printf statement at all. What if, on the other hand, if I change it to greater than 0, and instead of subtracting 1 each time, what if I add 1 each time? So x is equal to 3, 3 is greater than 0, we'll definitely go ahead and print x is equal to 3, and then we increase x and set it to 4. Well, we go back up and we test, is x greater than 0? 4 is greater than 0, so we end up printing x is 4. So what happens when I run this is it's something called an infinite. Computers really fast calculating all these, but x is just getting larger and larger and larger, and x is always greater than 0. So this will not stop until we run out of memory or a done computer. So if I need to stop this because I made a mistake programming, I'm going to hold down Control and hit on the keyboard, and it'll go ahead and stop and terminate that program. So that's called an infinite loop. So what the error was in that case is instead of getting larger, my x needs to get smaller, and then I'll go ahead and exit. So when you're coming up with the expression that's going to be either true or false, and it's going to decide whether or not to go inside of that loop, there's a couple things that are good to know that we haven't talked about yet. So I'm going to just move this over here. There are some relational operators. We've talked about equal for our two sides of an equation exactly equal. You can do the opposite with a tilde equal. Our two sides of the equation not equal. Then we've got greater than or equal to, less than or equal to. And then you can make more complicated expressions. I'll give you a few examples of these with a logical and with shortcut evaluation, and I'll talk about that later, or with a vertical bar. There's a logical OR with a shortcut evaluation, and there's an exclusive OR and a logical not. So let's try a few of the confusing ones. So the first one I'll do is not equal to. So if I have two sides of the equation, let's say my x is 0, and I want to say, is x not equal to 5? Well, 0 is not equal to 5, so that is a true statement. Another new one, the logical and logical or. So if I'm looking for the statement x equals 0, that is a true statement. The x value is set to 0 right now. We can see that in the workspace, and we could see it just by printing out x. So if I want to say, is that true, and is it also true that 100 is less than 3? Well, the second part of that equation is false, so if I say, is the first part and the second part true, that is false. Or is two vertical bars, and we're going to test, is the first part true, or the second part. Here, just one or the other have to be true for the whole thing to be true. And so I use double vertical bars and double ampersands, and the doubling it up is a short circuit evaluation. So if it figures out with an and, both sides of the equation have to be true. If it knows right off the bat that the first thing is false, there's no reason for MATLAB to even test the second half of it. So it's slightly more efficient to use the double and the double or. All right, I hope that makes sense, and I'll have another video soon.